So for the first question, most people got this one fine. If the bag contains 3 green Christmas ornaments and 4 gold, the probability of selecting a green will be 3 out of 7. Next one caused a little bit of problems. If you're going to pull 2 out at the same time, that's like pulling one then another right after. So the probability of drawing a gold first and a gold second will be equal to, and it'll be a 4 out of 7 probability because there are 4 gold in the bag out of a total of 7. And then after the first one is drawn, the second one will be a probability of 3/6. And that's the same thing as 4/7 times a half, which is 2/7. So the answer is B. Coin is tossed 3 times. This is an independent event, so the probability of heads, heads, and heads is going to be equal to 1/2, which is the probability of flipping a head on the first coin, times 1/2 times 1/2, which is 1/8. So the answer again is B. Next question, 2 standard dice are rolled. What's the probability of rolling doubles? Well, the probability of doubles is going to be, there are 6 outcomes. You can roll 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And there are a total of 36 outcomes when you roll 2 dice. So the answer is 1/6 or A. And if you're programming a CD in random order, what's the probability that it will play your 6 songs in order from your favorite to your least favorite? Well, the probability of that, now this is dependent events, the probability of your favorite song being played first is 1/6. Then you've got 5 songs left, so the probability of your second favorite song will be 1/5, and so forth. So your third favorite, fourth, fifth, and your least favorite. And so when you multiply all this out, you get 1/720. So the answer is C. Now, you're asked to draw a tree diagram here, and if you roll a 4-sided die, it's going to be, the outcomes are 1, 2, 3, and 4. And so for every one of these, there are then 6 possible outcomes on the 6-sided die. And we could continue this. Now, since there's 6 outcomes for each of these, there's 24 outcomes total. Okay, so this would continue. Excuse my mess here, but you get the idea. So there's going to be a total of 24 outcomes. Now, what's the probability of rolling doubles? So the probability of doubles in this case, well, you could roll 2 1s, 2 2s, 2 3s, and 2 4s, and that's it. So out of the total, it's going to be 4 out of the 24 outcomes, which is 1/6. So for the next question, what's the probability of rolling an even number or multiple of 3? Well, if I circle all the even numbers of our 24 outcomes, you can see that there is a total of 12. So the probability of even or multiple of 3 is going to be the probability of even plus the probability of a multiple of 3 minus probability of even and multiple of 3, because you can have even number and multiple of 3, which is our 6. So if I circle in red the multiples of 3, okay, so there's a total of 8 multiples of 3 out of the 24. So this is going to be 12 out of 24 probability of even, plus 8 out of 24, which is our probability of a multiple of 3, minus the probability that even and multiple of 3, which is our 4 sixes. So that comes out to be 16 out of 24, which is 2/3, or 66.6 repeating percent. Now, the key word in the next question was independent. So we're told that these are independent events. So the probability that they play baseball and volleyball is equal to the probability of playing baseball times the probability that they play volleyball. Okay, so this is the rule for independent events. So the probability that they play baseball is 0.47 times the probability that they play volleyball, which is 0.52, which comes out to be 24 point, or sorry, it's going to be 0.24, which is works out to be 24.4 repeating percent. So the probability that they play baseball or volleyball will be equal to the probability that they play baseball plus the probability that they play volleyball. And because people can play both volleyball and baseball, these are non-mutually exclusive events, so we have to subtract off the probability that they play baseball and volleyball. So this works out to be 0.47 plus 0.52, subtract 0.244. And that comes out to be approximately 74.6%. All right, the next question. We have a total of 29 marbles in the bag, and we're going to draw. We want to know what the probability that you draw blue first, red second, blue third, white fourth and fifth, and red last. So the probability of that order is going to be equal to the probability of drawing a blue first. Well, there's 9 blues out of 29 marbles in the bag. Then on the second draw, we want to know there's going to be 8 reds out of 28 marbles left in the bag. Okay, and since there's no replacement, then for blue third, well, we drew 1 blue in the first draw, so there's 8 out of 27. And then white fourth, well, there's 12 white in the bag out of 26 marbles left. And then white fifth, so there's 11 white in the bag because we drew 1 in the previous draw, so that's 11 over 25 times red last. We drew a red on the second, so now there are 7 red left in the bag out of 24 marbles. And so when you multiply this out, it comes out to be approximately 0.156%. Now the probability that you draw all blue